Hello, my name is Andrew Grau, and this is my Physics 1 Lab 1 constant velocity lab report. So the purpose of this lab is to observe the position versus time of an object with a constant velocity and compare it to a predictive model also with constant velocity and zero net force. For this lab, I used Tracker, GlowScript, and Excel as softwares, and the principles at play were Newton's second law and the kinematic equations. The main result of this lab was just the velocity graph of the observed model was very similar to the velocity graph of the predictive model, which uses a constant velocity and zero net force assumption. So the main physics ideas at play here, this is the position update formula. We'll have zero acceleration, so it's just the left side of this formula. Our velocity formula, just change in distance over change in time. And then for a constant velocity, it's equal displacement over equal time intervals. And then Newton's second law here, so just the net force is zero when all external forces acting upon an object are balanced. So moving on to the experiment description. So what we used is a weighted car, and we just rolled it across the table. So we gave it an initial push, and then we cut the frames to where the video is only analyzing parts of the car that were moving at a constant velocity. So we kind of cut the end and the beginning of the video out. And then obviously that is our system there. And then you can see this blue line, that was our kind of zero, or like our measurement. We had the yardstick back here, but we ended up just using the distance of the car, which was 17 centimeters, and that's fine because you get the same results. And then, like I said, this is our system and this is the surroundings. And then the assumptions on this, just low friction and no air resistance. And then our initial conditions, obviously our position was at x equals 0, and our initial velocity was 0.3456 meters per second. So into the program model. So some of the assumptions I made in the program was that the ball velocity was that 0.3456, just so it matched our real world example. And then the delta, so the difference in time, was 0.033 seconds. The maximum time was 2.167 seconds, which is just the end time of the frames that we were analyzing in the real world video. Force net is equal to 0. You have to do that to have a constant velocity. And then our equations, our velocity, since it's constant, is just equal to the velocity. Then the position, obviously that's just our position update formula as well. And then these are the outputs from that program in GlowScript. And then the explanation of assumptions. So this is the calculation for the V average, just the final position minus the initial position, and then the final time minus the initial time. And then you can see where that delta came from as well. It's from the clip settings there on Tracker. So conclusions, so as you can see, the actual experiment deviated a little bit from the simulation, but they were very, very comparable. And some sources of error for why it might have deviated was just the initial force applied, so the acceleration, it did take time to get to an apparent constant velocity, but it's still very close. And then the path of the system, we tried to make it a straight line as much as possible, but there might have been small deviations. And then the tracker software particulars, so obviously you're clicking each frame, and there might be some deviations between where you click. So moving into the what if, so the axis doesn't really matter for your final answer. You'll end up with a constant velocity either way. It just matters for if your values are positive or negative, obviously, which mine actually were going into the negative x-axis if you look at my tracker slide. But I just changed the values to be positive because you get the same constant velocity anyways. The only difference is your positive or negative sign. But like I said, it's just the same. It's just a constant velocity. And then there's not really a way to know how many pushes or pulls there are, just because the net force has to equal 0, and there could be any combination of things added together with different values, unknown values, and an unknown number of things to get to 0. So you can't really know. But yeah, that was my constant velocity lab report, and thank you for watching.